So, with this sensor, we've set up as a aux or the analog input. So, the way that this works is it takes the aortic signal from the HEMO box from the analog port of the HEMO box. So, you only need one cable after you've set up. You only need one cable from the HEMO box, and the other signal comes from the wire itself. So it's really tidy. Generally, you find that a lot of sensors don't use their analog port, so it's free. And if they do, you can use a splitter, and then you can just put that in, and then they've got both setups simultaneously. So all the ports on the optical unit are color coded. So the cables, the color of the cable lines up with the color of the port. Now, there's one to be wary of is the two yellow ports. So if you're doing a transducer setup, so direct from the transducer, which then takes the aortic signal into this, and then we have to output that aortic signal from the transducer into their HEMO system. So there's two ports. There's a yellow port, which is the distal out, and there's one that's the aortic out. In that setup, you want the aortic output and the yellow cable plugs the aortic output then into their HEMO system.
So you plug this wire?
So if you're using the transducer setup, you will have two cables. One coming from the transducer, which goes into our aortic in or aortic transducer, and then the output cable, which sends the aortic signal from the transducer with the signal from the distal from the wire itself out into their hemodynamic system. So it depends. There's two different setups you can use depending on the lab, depending on how you use it. So that way you can also use it as a integrated FFR. So if they have integrated FFR, they want to use that, you can use that setup. This one, everything with the analog, everything is on here. So you don't need to feed back to their system. You can with the other. Now with the transducer setup, with the analog setup, sorry, you do need to calibrate the system, which means the other yellow port, the distal out, needs to be plugged in for that stage. Probably best going through that with, there's a more in-depth presentation. It depends on the system, how you calibrate it and stuff, but it's all pretty much the same. So we are unplugged at the minute, so I can't really show you anyway. But the idea is that once you're calibrated at the start, you can then unplug that and then just leave the analog setup in. The transducer setup, you don't need to calibrate. There's advantages of both. Depends on the lab. I think this one's nicer. It's tidier. There's only one cable, and once you set up, it's really simple. You can't really mix because you can easily jumble your yellow wires. The green is just one connection.
Right.
Should we plug in?
Yeah.
Do you want to pause for a minute? Where's the... So this, we have two power box for this. You can get a splitter, which is probably a bit tidier, which just has one kettle lead and then a splitter for both power box. So we plug these in. So the main thing you're looking for with these lights, they're not there just to look pretty. They have, each one of them means something different. So this is your optical power. This means everything's booted up. It's got power from the source. If that's off, you're either turned off here from this button, or you're being unplugged somewhere, or it's broken, basically. But that's less likely. This one is if you're using the wireless connection, which you have to first wire in with the blue cable for into the comms port, which then plugs into the LAN port on here. This one is your the electrical connection of the handle unit. So when your wires plugged in, this one's the light connection. So this is these two. So this is your power signal that sends to this. this is your optical signal, which sends a light beam through this. When you're connected, if either of these two are missing, this is a full presentation. I've got a presentation on this, to be honest. I don't know, I'm trying to do it from memory. But this is where you need your troubleshooting guides, which we can sort you out with. So any of these aren't working when they should be, that's when you need to troubleshoot in terms of what's going on. So when you first plug your wire in, you want these two. This should also come on. This is the 0, so this means it's been properly zeroed. So the other way to check for that, on the handle unit itself, you can see there's a yellow light. That's because there's just a single blink. That's because nothing's connected. When you connect your wire in, this will turn green. You'll get a nice audible beep. And this should also come on to say it's been zeroed successfully. The last one is the EQ. So it's like an EQ desk on a mixing desk with a signet symbol. So that's only when you've equalised. When you've got all of these on and you're all ready to go, so everything's been done up to that point, these should all be on before you start. Otherwise, something's missing. The other way to check is on the screen itself. There'll be little messages to say if there's something something's missing. So I don't know if they come up in the middle anymore. They used to, but they'll stretch out here. We always recommend keeping the sound on both the display unit (DU) and the optical unit (OU), because if there's something going wrong, it's just it'll make a noise, basically tell you. So when you plug in, it beeps to let you know it's plugged in. It's a nice connection that the clinicians can make as well, especially if they're disconnecting the wire. When they reconnect, they'll get a little beep, which lets them know that it's been a successful reconnection to the wire. What else to tell you? So, all the maintenance codes come as standard as 0750. I've taken this one off, which is the tick. So this is what I was saying about the calibration. This is a separate presentation, to be honest. I can't all fit it all in one video. It's just going to be a jumble. But the idea is that you want to set your 0 point and also the top point. So you want your 0 to be accurate. So this is basically the system feeding in from the aortic. The aortic reading that comes from the system, you want that to be 0 on both, the same 0. So when you've got your yellow cable into the distal out, what you can do is you can, with the output here, set this to 0, which sends a signal to their system because you're plugged into their P1 rather than the signal from the transducer. It sends a signal to their hemo system saying 0. So if they're 0 and that's 0, this should also read 0. Obviously we're not connected now, and their aortic signal is 9.3. So the idea is you want this to be the same as that. If it's not, you make adjustments. So set this to 0, wait for that to go to 0, and then with these you can offset the number so that this reads the same as that. So if you look, each one is 0.01, either up or down, and it will change the corresponding signal. The gain is the top end, so that's the higher number. So we set it to 200, which then sends a signal to 200 on here. You want this number to be the same as this number again. So you want whatever this number is, it could be 199, that's fine. You just want to match this number with this number on here, which with the gain. And it's the same, up or down. So it could be that this is 198 from the 200 output. It doesn't matter if that's not 200. The main thing is you want this to match that, because that's where you're getting the signal from for the calculations. Once that's all set up, the other thing you want to do, we'll change it, no. The other thing you want to do is check your pressure wire delay. So when you're still plugged into theirs, you'll get two traces from the signal it sends out will also give you the similar appearance of the aortic trace. And the idea is you want these two to line up so that they're together on the screen. When you equalize, it should do that anyway to some degree, because the idea is it's bringing the pressure signals close. However, sometimes it can be off by a few milliseconds, in which case you're just looking for both of the lines to be superimposed over each other. So you should only see the one line essentially, and you just do just that with this. So I'm not going to do anything here, but that's the basics of the calibration for the analog. And then you should have a nice appearance. Are we going to do some training tomorrow with the